Welcome to this video tutorial about the software package test.con 6 Studio. This tutorial will be no step-by-step tutorial. I will just give you some basic information about the software and some Gantner devices. In the next videos I will give you step-by-step instructions. First of all, I will talk about what is test.con 6 Studio, then which devices can be programmed with test.con 6, and why do I need the test commander, and how do these tools work together. After that, I will give you a short look into the Q.station. The Q.station is the most complex device in Gantner family. To program the Q.station, you will need to know some information given in this video. And the last point is what is test.con runtime? And I will just answer some basic questions. So what is test.con Studio? test.con Studio is a graphical programming system for signal processing of test controllers of the Gantner family. For example, you can evaluate input signals or use filter functions to damp input signals. You can basically do everything that you could do with a classic signal processing function. Furthermore, there's a large library available. What you can also do with test.con is a classic automated test process. For that matter, classic logic functions known from PLC programming are available for programming the function block libraries. To generate a totally controlled process, there are PID controllers available. So it is really possible to program a complete automation of test process with test.con. The test controller is often used to generate a test signal. So signal generators are needed for that matter. If the reaction of the test object has to be measured, an input signal can be applied, and this can be realized with test.con 6 Studio. It became necessary with the Q.station 101DT to program a human-machine interface, so the display of the Q.station can be programmed. Other displays and other systems can be programmed with test.con 6 Studio too. How does it work to program with test.con? First of all, there are three programming languages or programming patterns: function block diagram, flowchart, and sequence chain. You can see a function block diagram in the upper corner. Classic function blocks are placed on a worksheet and then connected by signal lines. That is how an application is built, one block after another. Especially for programming a batch-oriented process or test process, flowchart programming is used. I would like to shortly show you what I mean, but as I have already said in the beginning, this video should only give you an impression about the surface of test.con, how it looks like and how test.con works with Gantner devices in general. What you have here is a worksheet with several different tree views from which resources necessary for programming are taken from. Later on in this tutorial, I will give you some more detailed information about that. I would like to quickly show you logic programming with logic functions like AND, NOT, OR, and XOR. You simply drag the blocks into the worksheet and then connect them. So the application is programmed step by step. This also works in the analog section with float. There are many functions which can be used for that. Here you can see the different libraries, which provide many possibilities to create the application. How to specifically work with test.con will be topic of my next tutorials. Now I will quickly show flowchart programming, so you will have a short impression about that. Here you see sequence chain programming, which can also be used in test.con. Which devices can be programmed with test.con 6 Studio? Not only the Q.station, but also older devices from the e.series can be programmed. However, only the old function blocks are available. If there is an update sometime, new function blocks will be available. Classic devices from the current Q.series, which you can program with test.con 6, are Q.pack, Q.gate and the Q.station. Derivations like the Q.res and Q.bricks are also included and can be programmed with test.con 6 Studio. Up here you can see a more special device. This is the test.con runtime. It is a Windows PC which you can program. However, I will talk about it a little later. Here you can see test commander and test.con. How do test commander and test.con work together now? You are not able to configure test controllers like the Q.station, e.pack or e.gate or others with test.con. You will additionally need Test Commander. If you already know Gantner Devices, you already know the Test Commander, and you know how comprehensive the configuration can be. But first I'm scanning the target device, which is the Q.station here. I read the standard configuration, which the system has scanned itself. It recognizes the connected module. On basis of the default configuration, I can adapt my own configuration to my needs. For example, I can designate an I/O as a current channel, or I can designate an input to be a voltage channel. Or if I want to work with 4 to 20 ampere at some point, that's possible to configure with test.con. And you can also assign variable names, etc. You'll probably know that if you have already worked with Test Commander. When the configuration is done and cycle time is implemented, the configuration has to be downloaded on the Q.station. If I now go on the Q.station with test.con, I will not need the Test Commander anymore. Configuration is read directly from the Q.station. On basis of this configuration, I can write the test.con program. There are specific variable names available for the I/O channels. So for example, I know the exact channel from which temperature is read, and I can say, okay, this module here is the control input. I can trigger directly in the application. That means that I write a specific application program on the basis of this configuration. This program will then be downloaded on the Q.station, and it can work autonomously and independently. So the execution order is to first create a configuration in Test Commander and then program the application with test.con. Physically, the Q.station is only one device, but logically there are several devices. Here you can see the inner structure of the Q.station. When scanning the Q.station, you will see the following. I will quickly show you. I am scanning our office network now, and it finds a device which is the Q.station. And it also finds the real-time kernel and a Linux kernel. Logically, those are two different devices. That was this device that was found. This is the real-time kernel. What was also found is this device. It is a Linux process and a microkernel process. What wasn't found is the process for the startup, but that is hidden for the user on purpose, so they cannot change the programming of the startup. What was also not found are other kernels, as they are not set up on standard controllers. Theoretically, there are several kernels, which means in one Q.station there are logically several devices, and at least, or at the moment, there are 3. The start app, a programmable user kernel within Linux, and a real-time kernel which is called directly as real-time task within a microkernel. What you can see here is the rough structure. From outside, the device seems like a Linux device. However, Linux itself is only one task within the R-time microkernel, and within this kernel our real-time task will be called. We are dealing with measurement systems here, so we have totally different requirements than we know from the normal office world. So that is why there is this task which completely runs outside of Linux. If Linux now crashes completely, it won't matter to the application, even if Linux has to process tons of processes, because it is dealing with the screen or some complex algorithms are being processed. The real-time task will not be interrupted. Here I have the possibility to reach cycle times or refresh rates of up to 10 kHz, which means I will reach a cycle time range of up to 100 microseconds, and it will be executed in real time. So we are dealing with a real-time operating system. In this cycle range I can also use PID controllers, which can also be performed in real time. It does not matter what Linux does at that moment. Within this microkernel, the whole data acquisition, which means reading and writing the I/Os, is running all within the microkernel. Here is a short impression on test.con runtime. So what exactly is test.con runtime? In general, it is nothing other than a small Windows program, which is running on a Windows PC. This Windows PC or this Windows program pretends that it is logically a user task within the Q.station. That means, if I want to program a test.con runtime, I log in at the Q.station, which is exactly the partner with which the test.con runtime should communicate. So a test.con runtime exchanges data with a test controller, which can be, for example, an e.pack or e.gate, and it does not necessarily have to be a Q.station. Just exchanges data with a test controller from the company Gantner Instruments over Ethernet. For the system to know with which device it should program, I have to log in with the test.con runtime at the target system or the communication partner during programming. It is the same as if I would program a test.con runtime, which is a user space kernel within a Q.station. There's only one advantage or one change. I do not only have the small screen available, I have the screen of the PC and I have all possibilities which are available on the PC. From a logical point of view, the kernel seems as if it is running down here. However, the kernel does not run down there, it is running on the PC, and there I can also program superimposed automation functions. But what do I need that for? For when I implement my real-time operation and other important functions, I can process up here bigger superimposed applications. I can actually put a master computer above which controls the system. There is a big control panel, so I can use the system as visualization extension of the Q.station. Or if I use a device like, for example, Q.pack or e.pack, for which I do not have any visualization possibility, I will get one with the test.con runtime. So that was it for this tutorial. In the next tutorials I will go further into test.con 6 Studio and I will explain how to create a project and how I can program a real-time application for the Q.station, or how to program a user space application for the Q.station, and how you can connect the user space application with the real-time application. For example, to get parameters in the real-time application or read values from the real-time application. Thank you for watching and I hope I could be of some help.